The lecture that shook the stars. Professor Thaddeus Drake adjusted his collar as he surveyed the grand amphitheater of the Galactic Academy of Sciences. The massive chamber, designed to accommodate beings from across the known universe, hummed with anticipation. Crystalline beings floated in anti-gravity pods near the ceiling, while amorphous energy entities pulsed in their containment fields. More conventional aliens, those with physical forms, occupied the tiered seating that spiraled down toward the central podium. Distinguished colleagues, Drake began, his voice steady despite the nervousness fluttering in his stomach. Today's lecture covers a subject that has been widely misunderstood throughout the galactic community, my homeworld, Earth. A ripple of unease moved through the audience. Several luminescent Philorians dimmed their bioluminescent appendages, while a group of ZX-Theri pulled their environmental shields closer. "Professor," called out Academic Director Veer-Leth, her crystalline form chiming softly as she spoke, "we must protest. A Class 13 Deathworld is hardly appropriate subject matter for Class 14, Drake corrected, allowing himself a small smile. Earth was reclassified last stellar cycle. The resulting chaos was immediate. 3 Mindweavers from the Rigel system fainted, their telepathic shock waves causing several nearby students to experience sympathetic dizzy spells. A delegation of Jovian academics began stress molting, filling their section with iridescent scales. Drake raised his hands, waiting for order. "Please, colleagues." This reaction precisely illustrates why this lecture is necessary. How can we claim to be scientists if we allow fear to prevent us from studying one of the most unique crucibles of evolution in known space? He tapped his datapad, and a hologram of Earth appeared above the podium, a beautiful blue marble suspended in space. Several audience members relaxed slightly at the peaceful image. "Let's start with basics," Drake continued. "Earth's gravity is 9.8 meters per second squared." He paused as several beings made distressed sounds. "Yes, I know that's roughly 3 times the galactic average for life-bearing worlds. Now, consider our atmospheric pressure." The next hour was punctuated by gasps, murmurs, and the occasional activation of emergency meditation pods as Drake methodically described Earth's normal conditions. The concept of weather particularly disturbed the audience. "You mean to tell us," interrupted Professor Zilax, her tentacles twisting in agitation, "that superheated water regularly falls from your sky?" "Rain is actually one of our milder phenomena," Drake replied. "Would you like to hear about hurricanes?" The explanation of hurricanes led to the first evacuation of the day, as a group of gas-based beings from the Horsehead Nebula became so agitated they had to be escorted out by medical staff. "But surely," called out a brave student, "such conditions make technological development impossible? The energy requirements alone An excellent observation." Drake's enthusiasm made several empathic species wince. "Let's discuss human energy requirements. Who here is familiar with the concept of endurance hunting?" The resulting silence was deafening. Drake projected a new image, a human persistence hunter tracking prey across the African savanna. Humans can maintain pursuit for hours, even days. We literally chase prey until it collapses from exhaustion. We're one of the few species known to hunt this way. The academic director's crystalline form vibrated with concern. "Professor Drake, are you suggesting that humans evolved as pursuit predators in these conditions?" "Oh, no," Drake replied cheerfully. "We evolved as pursuit predators because of these conditions. There's a difference." He advanced to the next slide, showing human skeletal structure. "Our bones are dense enough to qualify as light armor by galactic standards. Our muscles are A high-pitched keening sound interrupted him as several more beings opted to evacuate rather than learn about human musculature. Drake checked his chronometer, only halfway through his allocated time, and he hadn't even gotten to the really interesting parts yet. He smiled, knowing that his colleague's reaction to Earth's basic characteristics was nothing compared to what would come next. After all, he hadn't even started on the topic of Earth's microbiome, or the fact that humans were one of the few known species to deliberately consume chemical irritants for pleasure. The lecture was just getting started, and already the Galactic Academy would never be the same. Survival against all odds. Drake advanced to his next series of holograms, displaying Earth's varied ecosystems in stunning detail. The Sahara Desert's endless dunes shimmered beside the Amazon rainforest's verdant canopy, while the frozen wastes of Antarctica gleamed next to the bubbling depths of underwater volcanic vents. What you're seeing, Drake explained, are just a few of Earth's biomes. Humans don't just survive in these environments, we thrive in them. A Vaporean scholar, their misty form condensing with concern, raised an ethereal tendril. Surely you don't mean to suggest that humans inhabit all these regions? Indeed we do, Drake confirmed. From the coldest poles to the hottest deserts. Here's something fascinating, humans can survive in temperature ranges from approximately -50 to +50 degrees Celsius with proper preparation. Without technology, we can handle roughly -10 to +45 degrees Celsius for limited periods. The Vaporean promptly dissipated into a shocked cloud, requiring emergency reconstitution from their backup containment field. Professor, called out Dr. Thrix, her crystalline structure flickering with academic interest, our data suggests such temperature variations should cause immediate system failure in carbon-based life forms. How do humans manage this? Drake's eyes lit up. Ah, that's where it gets interesting. We sweat. The resulting confusion was palpable. Drake projected a detailed animation of human thermoregulation. Most Earth mammals use evaporative cooling, but humans perfected it. We have roughly 2 to 4 million sweat glands spread across our bodies. When we overheat, we secrete water mixed with electrolytes, which evaporates and cools us. You deliberately lose water? A horrified whisper came from the Hydrogenian delegation, their liquid forms rippling with distress. Oh yes, Drake continued cheerfully. Up to 12 liters per day in extreme conditions. We then have to replace it by drinking more water. Several Hydrogenians merged into a collective panic puddle. But that's just heat adaptation. Let's talk about cold. Drake switched to footage of ice fishing in Siberia. Humans living in Arctic regions have developed numerous strategies for survival. Some populations have genetic adaptations for cold tolerance, but most fascinating is our technological innovation. The hologram showed humans in various types of winter gear, from traditional fur-lined parkas to modern thermal suits. We've learned to create microenvironments around ourselves, allowing us to function in virtually any condition. A brave student from the electromagnetic spectrum raised a wavelength. What about atmospheric variations? Surely different altitudes dash. Excellent question. Drake interrupted, causing several nearby empaths to wince at his enthusiasm. Humans have permanent settlements at altitudes ranging from below sea level to over 5,000 meters. The city of La Paz, Bolivia, sits at approximately 3,650 meters above sea level, where the air pressure is roughly 40% lower than at sea level. The academic director's crystalline form vibrated with growing concern. Professor Drake, are you suggesting that humans can simply adapt to such dramatic pressure changes? With some time, yes. Our bodies increase red blood cell production to compensate for lower oxygen levels. We call it acclimatization. Drake paused, considering his next words carefully. Though I should mention that some humans climb to even higher altitudes, for fun. The concept of recreational mountain climbing proved too much for several audience members, who had to be escorted to the meditation chambers. Drake pressed on, bringing up images of human settlements in various extreme environments. Consider our underwater habitats, our research stations in Antarctica, our mining operations that extend kilometers below the Earth's surface. Humans have even lived in space stations orbiting our planet for extended periods. A collective murmur of disbelief rippled through the remaining audience. Drake smiled, knowing he was about to deliver the coup de grace. But perhaps most remarkably, we've achieved all this while sharing our planet with approximately 8.7 million other species, many of which are trying to eat us, poison us, or otherwise cause us harm. In fact, let's discuss Earth's predators. Before he could continue, the emergency meditation pod usage reached critical capacity, forcing a brief intermission. Drake used the time to prepare his next section, which would cover the various ways Earth's flora and fauna had shaped human evolution. He had a feeling the discussion of venomous creatures would be particularly interesting to his increasingly unnerved audience. As the emergency medical teams worked to revive several fainted academics, Drake couldn't help but feel a surge of pride. His species might have evolved on what the galaxy considered a death world, but that crucible had forged humanity into something remarkable. And he was only halfway through explaining just how remarkable they were. The intermission lights began to flash, signaling the session would resume shortly. Drake grinned as he prepared his next series of holograms. It was time to talk about how humans had turned their survival adaptations into recreational activities. He particularly looked forward to explaining the concept of extreme sports to his already overwhelmed colleagues. Evolution's crucible. As the audience cautiously filtered back into the amphitheater, Drake noticed several new safety measures had been implemented. Additional stabilization fields hummed around the more sensitive species, and the medical response team had doubled in size. Perfect. Now that we're all settled, Drake began, let's discuss how Earth's unique conditions shaped human evolution. He projected a new hologram, a complex web showing Earth's evolutionary tree. The fascinating thing about Earth's evolutionary history is the constant arms race between species. For every defensive adaptation, there's a counter-adaptation. For every predator, there's prey that evolves to escape it. And humans, well, we developed something rather special. He tapped his datapad, bringing up a neural scan of a human brain. This is our primary advantage, not just intelligence, but a particular kind of problem-solving ability coupled with pattern recognition and tool use. Professor Nvrix, a quantum state being, manifested closer to the podium. Are you suggesting that Earth's hostile conditions directly influenced human cognitive development? Precisely. Drake beamed. Consider this, Earth has regular environmental changes, seasons, day/night cycles, tidal patterns. Species that could predict and adapt to these changes had a significant advantage. Humans didn't just adapt, we learned to manipulate our environment. He displayed a series of ancient human tools, each more sophisticated than the last. We started with simple stone tools, but quickly progressed to creating complex machines. But here's what's truly remarkable, we didn't just make tools for survival. We made tools to make better tools. The hologram shifted to show early human settlements. We learned to control fire approximately 300,000 years ago. Not just use it, control it. We could create it at will, maintain it, and use it for multiple purposes. A pyrovoid entity in the upper tiers flickered anxiously. You deliberately create plasma reactions? For cooking. Cooking, heating, toolmaking, social gatherings. Drake listed cheerfully. In fact, our mastery of fire fundamentally changed our evolution. It allowed us to extract more nutrients from our food, leading to bigger brains and more complex social structures. He paused for effect before delivering his next point. And speaking of food, let's discuss human dietary adaptations. The hologram changed to show various human foods. Humans are omnivores, but with a twist. We can digest an extraordinarily wide range of substances. Some things we eat would be considered toxic by most galactic standards. Like what? Someone called out nervously. Well, take capsaicin, for instance, the compound that makes certain earth plants spicy. It's literally a chemical deterrent evolved by plants to prevent consumption. We not only eat it, but many humans actively seek out increasingly potent versions for pleasure. The medical team rushed to assist several beings who appeared to be experiencing sympathetic pain responses. Or consider caffeine, Drake continued relentlessly. It's a plant neurotoxin that we deliberately consume to enhance cognitive function. We've built entire cultures around its consumption. The academic director's crystalline form vibrated with alarm. Professor Drake, are you saying humans intentionally consume defensive compounds produced by other species, for entertainment? Oh, that's just the beginning, Drake grinned. Wait until you hear about our fermentation processes. We deliberately let microorganisms partially decompose our food and drinks, then consume the results. Some of our most prized culinary achievements are essentially controlled rot. The evacuation rate increased significantly at this point, but Drake pressed on. He brought up new diagrams showing human cellular structure. But perhaps our most remarkable adaptation is our repair capabilities. Human cellular regeneration is quite impressive by galactic standards. We can recover from most non-fatal injuries given time, and our immune system. He paused as several audience members began showing signs of extreme distress. Our immune system actively seeks out and destroys invasive organisms. We have specialized cells that remember previous threats and can mount increasingly effective responses to repeated exposures. You mean, a horrified voice called out, humans are constantly at war with microscopic organisms? Constantly, Drake confirmed cheerfully. In fact, right now, my body is probably eliminating thousands of potentially harmful microorganisms. We call it our microbiome, and it's actually essential to our survival. The hologram shifted to show human medical achievements. We've even learned to use our understanding of this internal warfare to develop vaccines. We deliberately expose ourselves to weakened or dead pathogens to strengthen our immune response. This proved too much for the remaining mind-weavers, who had to be escorted out while broadcasting waves of stunned disbelief. Drake checked his chronometer, perfect timing for his next section. Now, let's discuss how these evolutionary adaptations influence human recreation. The price of paradise. Drake projected a sweeping vista of Earth's most stunning landscapes, pristine beaches, majestic mountains, lush rainforests, and crystal-clear lakes. The remaining audience members relaxed slightly at the beautiful imagery, though their relief would prove short-lived. What you're seeing, Drake said, his tone deceptively gentle, are some of Earth's most hazardous environments. He zoomed in on a gorgeous tropical beach. This lovely scene contains multiple threats. The sand harbors microscopic organisms that can cause severe infections. The beautiful blue water conceals predators and venomous creatures. Even the sun itself can damage human tissue within hours of exposure. Yet humans vacation there, asked a puzzled Heliosian, their plasma form fluctuating with confusion. Oh yes, Drake confirmed. We've developed protective chemicals to prevent solar radiation damage. We call it sunscreen, and we splash in those waters for entertainment. Sometimes we even deliberately seek out dangerous creatures for what we call wildlife photography. He switched to mountain scenery. These peaks experience extreme temperature variations, low oxygen levels, and frequent avalanches. Humans climb them recreationally. We call it mountaineering. The hologram shifted to show various extreme sports, surfing massive waves, skiing down steep slopes, diving into underwater caves. Each new image triggered fresh waves of concern among the audience. Professor, interrupted Dr. Tharl, their tentacles twisting anxiously, are you suggesting humans deliberately seek out dangerous situations, for pleasure? Precisely. Drake beamed. We even have a term for the chemical response our bodies produce during such activities, an adrenaline rush. Many humans find it addictive. He brought up new images showing Earth's natural disasters. But let's talk about how humans adapt to environmental catastrophes. These are what we call tornadoes, rotating columns of air that can reach speeds of over 300 kilometers per hour. Several gaseous beings compress themselves in horror. Some humans chase these storms for scientific research, and sometimes just for excitement. We call them storm chasers. Drake continued through his catalog of natural disasters, earthquakes, volcanic eruptions, tsunamis, explaining how humans had not only survived but studied each phenomenon. He described how communities rebuilt after devastation, often in the same locations, developing increasingly resilient structures and warning systems. But perhaps most remarkable is how Earth's dangers have influenced human art and culture, Drake said, projecting images of nature-inspired architecture, literature, and art. We don't just survive these conditions, we find beauty in them. We create art about them. We write stories celebrating our relationship with our dangerous world. He displayed examples of human literature describing epic battles against nature, tales of survival, and poems about the brutal beauty of Earth's most hostile environments. Consider this: humans often describe dangerous natural phenomena using terms of admiration. We call powerful storms magnificent, describe dangerous predators as majestic, and refer to volatile volcanoes as awe-inspiring. The academic director's crystalline form pulsed with bewilderment. You admire the forces that try to destroy you? More than that, Drake replied. We study them, document them, and sometimes, we miss them when we're away from them too long. Many humans experience something we call homesickness when separated from Earth's specific environmental conditions, even the dangerous ones. He projected a final image, a time-lapse of Earth showing the cycle of seasons, day and night, weather patterns, and tectonic activity. This is what we call home. Every challenge it presents has shaped us, every danger has taught us, and every threat has made us more resilient. The remaining audience sat in stunned silence, trying to process how a species could not only survive but thrive in such conditions, and more incredibly, love their deadly world so deeply. Drake smiled, knowing his final section would be the most shocking of all, explaining how humans had taken the lessons learned from their dangerous planet and applied them to space exploration. After all, what was the vacuum of space to a species that considered volcano hiking a pleasant weekend activity? Children of the Deathworld. Drake paused dramatically before revealing his final series of holograms, images of human space exploration. The remaining audience members, already reeling from previous revelations, watched as spacecraft launches illuminated Earth's night sky. Having survived and adapted to Earth's challenges, Drake began, humans naturally looked to the stars. But here's what's fascinating: we didn't seek easier environments. Instead, we took our Deathworld survival skills into space. He displayed footage of early space missions. When we first ventured beyond our atmosphere, we didn't wait for perfect conditions or completely safe technology. We strapped ourselves to controlled explosions and hoped for the best. Surely not, gasped a quantum phase being, their probability field fluctuating in distress. No species would willingly. Oh, but we did, Drake interrupted cheerfully. And when some of these early attempts failed catastrophically, do you know what we did? We studied the failures, improved our designs, and tried again. And again. And again. The hologram showed the International Space Station. We built this as our first permanent home in space. Notice how it resembles our underwater habitats? That's not coincidental. Humans took the lessons learned from surviving Earth's hostile environments and applied them to space exploration. He brought up images of Mars missions and lunar bases. We're currently establishing colonies on worlds that most species would consider uninhabitable. But to us? They're just another challenge, not so different from settling the Arctic or the deep desert. But, why? Asked Professor Nvrix, who had remained surprisingly composed throughout the lecture. Why push into such hostile environments when there are perfectly habitable worlds available? Drake's expression grew thoughtful. Because that's what Earth taught us to do. Every time we've encountered a hostile environment, we've not only survived it, we've learned from it. Each challenge overcome has made us stronger, smarter, more adaptable. He displayed a final series of images, human achievements across history, from the first cave paintings to modern space stations. Earth's harsh conditions didn't just shape our bodies, they shaped our minds, our culture, our very way of thinking. We don't just survive, we innovate, adapt, and ultimately thrive in conditions that would kill most species. But what truly sets humans apart, Drake continued, his voice softening, isn't our physical adaptations or our technology. It's our perspective. Where others see danger, we see opportunity. Where others see threats, we see challenges to overcome. Where others see a death world, we see home. The academic director floated forward. Professor Drake, are you suggesting that Earth's classification as a death world is incorrect? Drake laughed. Oh no, Earth absolutely deserves its Class 14 designation. It's unquestionably one of the most dangerous known inhabited worlds. But that's precisely what makes humanity remarkable. We're not great because we survived a death world, we're great because our death world taught us how to thrive anywhere. He shut down his holographic display, leaving just one final image, Earth, the beautiful blue marble, spinning slowly in space. My colleagues, you've been studying humanity all wrong. You've been asking how we survive on such a dangerous world. The real question is, how could we not become what we are, growing up in such an incredible crucible of evolution? The lecture hall fell into absolute silence. Even the usual background hum of environmental support systems seemed muted. Then, slowly, one by one, the remaining audience members began to signal their species equivalent of applause. The crystallines chimed, the energy beings pulsed, and the quantum entities synchronized their probability fields in appreciation. Drake gathered his materials, knowing his lecture had forever changed the galactic community's understanding of humanity. As he prepared to leave the podium, a student called out one final question. Professor Drake, given everything you've shown us, what scares humans? Drake smiled. Nothing, and everything. And that's precisely why we'll never stop exploring, never stop pushing boundaries, never stop seeking new challenges. Because Earth taught us that the most dangerous thing of all is to stop adapting, stop learning, stop growing. He looked out at his audience one last time. After all, when you grow up on a death world, you learn that anything is possible, and nothing is truly impossible. As the lecture hall slowly emptied, Drake couldn't help but smile. He still hadn't told them about human sports, roller coasters, or horror movies for entertainment. But that, he decided, would have to wait for another lecture. The galaxy clearly wasn't ready for everything humanity had to offer, yet.